So, I just kind of wanted to go over like some of the problems I have and I had in the last test, and just kind of show you the level of math and why Cal B is hard for some people. Um, this is an example question I pulled off of the review. Uh, Looking at it, if you know anything about integrals or calculus at all, you might see something with it, but I'm not gonna point that out. Um, we're gonna ignore that infinity for now. Um, just because that'll come up later. It's another whole basket we have to deal with. Let's look at this integral right here. Well, I don't know about you, but I'm looking at this. There's no easy way to integrate this. That plus 16 makes it kind of hard because this whole bottom section is a term by itself. So, and if you try to use substitution, that you get an x on top, and that wouldn't cancel out with anything. So you can't use sub it. Integration by parts. That also doesn't work. I mean, you could. I'll try to do it out here, but it's actually you can't because all the terms are the same. So it's all just one big geometric thing. So that I'm not going to show, but that doesn't work. So, um, to start off, finding the general integral of this. Um, what we can do here is this might work. This is a really weird integral technique. It's called trig substitution. We'll replace all x's in the term. We're going to equal to 4 tangent of theta. Why that is, just because it's a weird thing. It's a kind of need to know. Because we get the 4 because it's the square root of the 16 here. And if we end up doing that, it will help us work that out. So let's rewrite it down here. You got to replace the dx with the derivative. That's the same as 4 secant squared theta d theta. So we got to replace the dx with that right there starting off. So let's carry this down. Infinity, we got 4 secant squared theta over 4 squared is 16 tan squared theta plus 16. I'm going to pull the 16 and the 4 out, so we end up with 4 over 16 on the outside. That's the same as 1/4, so it's 1 over 4. Boop, boop, boop. 0, infinity. Secant squared theta over tan squared plus 1. Now, this tan squared plus 1, this is a whole interesting bit. If you know anything about trig identities, you'll know that sine squared of a term plus the cosine squared of a term equals 1. If we divide all of this by cosine squared, so if we just do this to the whole thing, that'll make it tan squared theta plus 1, because those cancel out and just leaves it 1, equals 1 over cosine squared is secant squared theta. And hey, wait a minute, that lines up there. So we can rewrite this thing I forgot the d theta up here. Sorry. And up here too. It's not important, but for completion's sake. D theta. And that just leaves us with a big ol' 1 we can integrate. That's a really easy integral, actually. So we're just left with the integral is 1 over 4 theta plus c. But we didn't have thetas to start with. We had x's. So back over here, we have to solve for theta. So if we divide out the 4, so it's x over 4 equals tan theta. So tan negative, the inverse tangent, is the long one, of x over 4. That's really, I should be looking at the paper, not my phone, while I'm writing. Equals theta. So we get the integral equals 1 over 4 tan negative 1 of x over 4 plus c. Well, it's a, we're back here. Whoa, there's an infinity. I mean, we've already taken up most of the page on this one problem right here. So, we got, gonna write the integral 1 over 4 tan negative 1 x over 4, same as we had over there, from 0 to infinity. If you know the graph of tan negative 1, it looks like this. We got 0, 0. We got two horizontal asymptotes, which means it never goes past those. It approaches, it gets infinitely close. And it looks kind of like this weird S shape. And this is negative pi over 2 and pi over 2. It never reaches those, but it goes on and on to infinity. That helps us out with this infinity over here, because at infinity, we know it equals pi over 2. So we can actually solve for this. So it's 1 over 4 and negative 1 of, doesn't matter, infinity over 4 is still infinity, minus 1 over 4 tan negative 1, 0 over 4, doesn't matter, that's just a 0. Oh, sorry. And it was, so we already discussed that tan negative 1 of infinity is pi over 2, so we get 1 over 4 pi over 2 minus 1 over 4 tan negative 1 of 0 is 0, so times 0, so that all cancels out. So this is our answer right here, so it's pi over 8 is our final answer to the integral of this. And it took up almost an entire page to do that.